Maybe other vendors will also catch up, like AMD, and create their own tiny little AMD box. Well, they did. This is AMD's answer to the DGX Spark. Brand new, just came out, and I've got a few things to say about it. But first, a quick word from the sponsor of this video. Merlin AI. It's an all-in-one AI tool, and they gave my audience a big discount. I keep multiple AI tools around because each one is good at something, but it gets really expensive, and bouncing between tabs breaks my focus. Merlin AI puts ChatGPT, Claude, Gemini, and more in one place so I can pick the best one for the moment, whether I'm coding, researching, or writing for a video. Watch this. I click the Merlin AI extension, chat with the web page to summarize what I'm reading, and pull out the important parts. And I even have my choice of models right at my fingertips. If I need something deeper, I turn on Deep Research, and it builds a clean, structured report from multiple sources. And it also has quick modes like Web, Academic, and Reddit search. If you pay separately, ChatGPT is $20, Claude is $20, Gemini is $20, and that adds up fast. Merlin AI is cheaper because they buy AI API access in bulk. APIs cost less than the $20 plans, and most people don't even use $20 worth of API in a month. And here's the discount. I click pricing, continue, it takes me to Stripe, I enter the promo code, and the total drops to $60 for the year. That's basically $5 a month. I don't know how long this deal will be available, so grab it soon. The link is in the description. If you watch this channel for a while, you already know the chip that's inside of this thing pretty well. All these came out in 2025. The B-Link GTR9, the GMK Tech Evo X2, the Framework Desktop, Minis Forum, MSS1 Max, and of course Asus has it in a laptop form as well. These are general purpose Strix Halo boxes. Strix Halo is the name of the chip that's inside of these. The official name is Ryzen AI Max Plus 395. So AMD took that exact chip and put it in this tiny little dedicated box and charged $4 grand for it. Yeah, that's the same price that NVIDIA charged for the DGX Spark when it came out. And my first reaction was, what? $4,000 for a chip I can already have cheaper? All right, look, what? Okay, surely the framework, 128, 2 terabytes. Oh, that's without any expansion. Well, the Minis Forum came down a little bit. This is the retail right now. And the GMK Tech Evo X2, 128, also came down a bit from 4,000. So the whole market kind of quietly drifted up to $4 grand while nobody was looking during the past year. In other words, AMD is not gouging you here. They're just right where everybody else is. And by the way, this is now officially the smallest machine that I've got. Smaller than the Framework, much smaller than all these other Strix Halo machines, and even a touch smaller than the Spark. It packs 128 gigs of unified memory, which means memory that can be used by the GPU, into that. So the question today is not the chip. We already know the chip. It's everything around it. Did AMD actually close the gap with the Spark, not on silicon, but on the stuff that matters when you sit down and use it? That's what I wanted to find out. Now, with this Ryzen AI Halo machine, AMD is targeting AI devs, just like the DGX Spark was. And to me, there are 3 groups of people looking at this thing and wondering if they should fork over the $4 grand for it. Group 1, developers, my people. And I'm gonna make this real quick because there really isn't much of a story here. For regular dev work, building code, running your stack, all the CPU bound stuff, the Spark and the M4 Pro are basically all very close. To get a sense of this, I ran my Mandelbrot test, which is a Python interpreted code, which pegs all the cores all at once. 1 and 2 and 3. All right, we got some noise going on here. And you can see every single core of every single machine is being used. And this is what it looks like while running. 164 watts on the Halo, 164 on the Spark, very close, and about 80 to 90 on the Mac. Since this is a multi-core test, they all can do code compilation pretty similarly. We got 17.3 on the Mac, 15.4 on the Spark, and 18.4 on the Halo. Of course, there's nuances here and there, but I don't think that this is the primary target audience for this machine, even though it can be used for that purpose. But should you buy a $4,000 machine just to compile code? Come on, you know the answer to that. There are way cheaper alternatives for that. If that's all you need, this isn't the one for that. And that's not why you're here anyway. You're here for the AI stuff. So that brings me to the next group. All right, group 2, the tinkerers. And this is where it gets good because this box actually comes with all the software pre-installed. LM Studio, Llama, both running with the Llama CPP under the hood. So Llama CPP is built on it. Lemonade is included. Comfy UI is included. So I thought I'd do a little performance measurements, and I've got Llama Benchy to be the client. By the way, if you're not familiar, check out Llama Benchy. This is different than Llama Bench. Llama Bench is part of Llama CPP. It gets built with it. However, Llama Benchy can be used with other inference engines like VLLM and SGLang and a bunch of other ones. I'm running Gemma 412B on all these machines. You can see the GPU output right here. Halo, Spark, Mac, and boom. And there they go. They do prefill first, then immediately switch to decode. And this is a race, folks. So here we go. You can see the GPU usage pretty high on all these. 97% here, 95% on the Spark, and almost 100% on the Mac. The Mac is actually done. Now, slightly different technology. On the Mac, we're using MLX. On the two other machines, we're using Llama CPP. That's the GGUF models. And I've shown in previous videos that MLX is a little bit faster than the GGUF models on the Mac. And we definitely see that in the live chart here as it's running. Oh, I can hear the fan. That's the new AMD Halo. It's got a little bit of a fan going on right now. And this is what the temperatures look like. By the way, the Halo box has ports venting on the top of the machine, which is interesting, which is gonna be limiting. You can't stack them like you can with the Sparks. Sparks go from back to front. Although stacking Sparks is probably not great either because it's probably the hottest machine here. So you'd want a little bit of space in between them. But these definitely, you don't want anything around it because there's vents on all the sides of the Halo. What do we got? Okay, Llama Benchy gives us two numbers that matter. Token generation is how fast it actually spits out and generates the text. That one is memory bandwidth bound, so it has to do with memory. Both the DGX Spark and the M4 Pro have a memory bandwidth of 273 gigabytes per second, and the Halo has 256 gigabytes per second, so slightly less. And this actually reflects in the token generation speed. So we get 26.4 on the DGX Spark, 24.6 tokens per second on the Ryzen Halo box, just a little bit higher on the DGX Spark, but the M4 Pro actually beats them both, 33.8 tokens per second. They're all pretty close. The other number you should look at is prefill or prompt processing. That's the compute heavy part. That's what the GPU does. So as far as generating tokens, the Halo actually keeps up with the Spark pretty nicely. That's the number you can live with if you're chatting with it and you're a tinkerer. By the way, I ran this previously. That's why I have slightly different numbers on the chart here. And in that case, the Halo actually beat the Spark. So they're very close. Now, prefill. This is the one where the Spark's CUDA pedigree shows up. And I'm gonna have to be straight about it with you here. I've shown this before on the channel. The Halo does about 650. The Spark, 2000. Let's call it 3 times faster. However, this is actually almost double the speed that I got on the exact same chip back last year. So even though it's the same chip, the advances in software since then have actually enabled faster prefill on this chip. Software matters a lot, and AMD has really been working hard on this. Now, for most of what Group 2 people will do, the prefill gap just doesn't reach you at all. If you're chatting, if you're streaming responses, or if you're running an agent in your editor, you basically will never feel it. Where you will feel it is the compute heavy stuff like giant context dumps or pure image and video work. I did a stable diffusion test, and here the DGX Spark was doing about 2.9 iterations a second and the Halo 1.3. And I had a hard time getting it to work on the Mac at all. There is a way, it's just I'm still working on it and didn't get it working. Bad Alex, bad Alex. But I didn't expect too much from the Mac because it's really good at generating tokens. It doesn't have that very compute heavy and compute intensive GPU in there. So it'll do the job, but let's keep going, shall we? Next time, get ready for the video better. Thanks.
Nice preparation, Alex.
Okay. I also did WAN 2.2 video generation. This one was kind of nasty. A 5-second clip on the Spark takes about 5.5 minutes and 75 minutes on the Halo. Yeah, I was expecting a little bit faster on the Halo, but TBD. TBD. Oh, just a note. This is Windows also. There is a catch to that. And I showed this in a recent video about specifically AMD chips and how they behave with Linux versus Windows in prefill scenarios. That's another video. I'll link to that down below, but hold on. I got something coming up. You just wait. Anyway, none of this should surprise you really. The Spark is a CUDA machine top to bottom. That's what it's for. The Halo was never trying to win a compute drag race here. It's a different kind of box. Let's keep going. Now, for the twist. AMD put out their own benchmarks. It's right here. I'm looking over here because that's where my laptop is. If you just go to the homepage of the Ryzen AI Halo, you'll see everything about it. By the way, available at Micro Center. You can pre-order it right now. The ultimate AI dev platform. And these are exactly the machines they're comparing it against. According to AMD, the Halo doesn't just keep up with the Spark, it beats it in certain situations. Look at this. Token generation head-to-head with a Spark on the GLM Flash 30B model, up to 40% faster. Qwen 3.5 122B, 12% faster. GPT-OSS 120B, 7% faster, and Qwen 3.6 35B, 4% faster. Across the board, Halo wins in these particular models. And if we go slightly up here, they're doing image generation against the Apple M4 Pro. 3, 4, even up to 7 times faster. So case closed, right? AMD wins. Now, hold on. Let me just say up front that I'm glad AMD actually put real numbers out there at all. Most companies just give you like a chart and a vibe and a render. But every benchmark slide ever made is a company showing you their best angle. So the best we can do is just read it carefully and fill in the parts that didn't make the slide ourselves. Now, first of all, against the Spark, AMD shows only token generation here because that's the number that Halo is really strong at. So I get it, but they skip prefill here. That's the number where the Spark is 3 times ahead in certain cases on certain models. So here you're seeing the half that looks best. And that tells me that Group 2, the Tinkerers, is actually what this is for, because prefill is more useful in professional situations. Second, the image generation stuff. This is not against the Spark at all. This is against the Apple M4 Pro, which makes sense once you remember that the Spark actually wins image generation 2-to-1 and video by 16-to-1 in my case. I'll have to test Linux later. So here you're seeing a real win for the Halo, just against different opponents than the headline implies. Third, if you notice here, they're using mixture of experts models here. And that happens to work really well with 128 gig machines, because you can fit pretty big models like GPT-OSS 120B and Qwen 3.5 122B. But the number of active parameters is that second number. I don't know how many active parameters 120B has, but Qwen 3.5 122B has active 10B, A10B, and Qwen 3.635B active 3B. So the 3 billion parameters is actually active in that Qwen model. Finally, the price. Now, there's a footnote on this page at the very bottom here. They tell you about the test that they performed, and they also mentioned that the retail price for NVIDIA DGX Spark is $4,699. And for a few months, it was. It came out at $4,000, and for a few months, it was $4,700. Then it went back down to $4,000, and now it's back up to $4,500. Why does that matter? It doesn't matter in the grand scheme of things, but in some of their results, they're actually showing more tokens per dollar line. It's going to be kind of hard to pin down that number at this point. Sometimes it's true and sometimes it isn't. So where does that leave Group 2? Well, in a really good spot. On raw speeds, it's a trade. The Spark takes prefill and compute, while the Halo ties on token generation and brings the memory. So for things that you do all day, like chatting, Olama, LM Studio, running agents in VS Code, this thing will be just great. And there's one more thing, and that's the best thing. And this is kind of an exciting time for AMD and these machines, because every model and every tool that I threw at this box just worked without me fighting it. This was not the case last year. So just to validate the claims on the site, I'm running Qwen 3.6 35B. Actually, the Spark is a little bit faster here too. And this pretty much matches exactly to the memory bandwidth. So yeah, but look at prompt processing here. 1014 tokens per second on the Halo, 1783 tokens per second on the Spark. Halo is more than half at this point. Now, it may seem like the Spark is better, but there's a couple things that this box has that the Spark just doesn't. First, the DGX Spark is an ARM-based machine. NVIDIA Grace CPU, ARM. So it runs Linux for ARM. This thing, it's boring old x86. And I mean that as the highest compliment, because x86 means everything just works. My whole tool chain just runs with no caveats. I can install Visual Studio and just go with no emulation, no ARM version of anything. For a developer, that's massive, because contrary to what you'll see all the loud people say in the comments, we want Linux. Actually, most of the world still runs on Windows. But I think with AI, things are slowly shifting towards Linux. And there's good reasons for that. There's one other thing to know about x86. It runs a little warmer than ARM, even though the power usage at full tilt is actually about the same between these two boxes. And the Mac is just... It's just the Mac. It sips the power. Now, I did run this thing continuously for a while, and this bottom metal part got pretty toasty. Not a deal breaker, but another reason why you wouldn't want to stack these boxes. Also, x86, the price you pay for running everything under the sun. And that's why it also comes in two ways, a Windows version and a Linux version. You get to pick your own. The Spark is Linux only. Take it or leave it. By the way, if you buy the Windows version, you get the Windows key for the same price, and then you can install Linux on it. One more thing, there is an NPU inside here, up to 50 tops. The Spark doesn't have that, and it's not either or. You can actually use the NPU alongside of the GPU and the CPU. Well, Alex, what do you do with the NPU? Who cares? The NPU is very efficient. Now, it's true that there's not too much software out there using the NPU right now, but things are being built, like Lemonade Server, which actually comes pre-installed here. And this allows you to run basically all the same old models, but using a hybrid approach. You can use the NPU for the prefill part and the GPU for the decode part. There's a bunch of familiar models. They come in CPU versions, hybrid versions, and NPU only versions. Interesting. DeepSeek NPU version only. Write a paragraph and go. There it goes, and it's fully on the NPU. It's not the fastest thing in the world, but it's only using 50 watts of power. So if we go back to my video about the Spark from last year, Strix Halo, really good platform. They put out the chip, they said, here you go. The chip is here, they gave it to people, but software is still catching up. Yeah, that's what I said back then. But this box right here is actually AMD's answer to that criticism. Maybe not this box, but what this box comes with. As soon as I unboxed it and turned it on, the software is already there and ready to go. Pre-installed and pre-configured. There are no drivers to chase, no fighting Rockham for an afternoon, and no guessing which version of Python is installed. LM Studio, Olama, Comfy UI are all ready to go. Lemonade Server also, with Rockham support from day zero. This is not your grandma's Strix Halo, okay? This is the new Strix Halo. And they didn't stop there. AMD got these playbooks on their site now. Actual step-by-step guides getting AI workloads running. Look, they've got AMD Ryzen AI Halo. They've got AMD Ryzen AI APUs, like Strix Point APUs, for example. And then Radeon ones are coming soon as well. But under here, under the Ryzen AI Halo box, this shows you step-by-step, even filterable by beginner, intermediate, and advanced. Ooh. Clustering 2 Ryzen AI Halos. Interesting. Oh, hang on just a second. Yeah? Oh. Thank you. Oh yeah. Remember, there are 3 groups of people. Group 1 developers, Group 2 tinkers, and then there's Group 3. Don't forget about that, because I couldn't answer them with just one machine. I needed to have 2. That video is coming soon. Make sure you don't miss that. In the meantime, you can watch this video right here. Thanks for watching, and I'll see you in the next one.